So we're going to have a look at extracting value from images, but working on a sort of a different variation of raster. So Bill Gates said 640 kilobytes of RAM is enough. I mean, I've got a relatively low-end phone and I'm carrying sort of 2 gig of RAM around with me in my pocket, and there's probably people in the room who've got 8 or 16 gig of RAM in a more high-end device. So Bill, slightly not good at that for a prediction. He's quite good at a lot of other things. Dale Lutz is one of the co-founders of Safe Software, and he said FME will never do raster. So he was definitely wrong. Safe have introduced all sorts of sort of capabilities in terms of data formats over the years. But raster was pretty early, really, 2007. If you scan that, you can go to the original release document. And basically, for me, users in 2007 who'd been very used to using FME to process Excel and shapefiles and mapinfo tab files and spatial and vector data, all of a sudden got access to raster data and could read in bitmaps and PNGs and GIF files and Mr. SID compression, ECW compressed files, you name it, and got all of the transformation capabilities that vector users had required and used over the years. So, you've got aerial imagery, you've got digital elevation models, you've got the ability to clip and tile and reproject and rubber sheet, stretch and fit aerial imagery and data, tile it, resample it. But all of that's kind of traditional use of FME, and you've heard all of that before, so I'm not here to talk about any of that. What I am here to talk about is the stuff that we are capturing with our devices all the time. Photos, images, and I'm going to talk about squirrels and sheep and vehicles and office spaces. And the reason for that is that we've tripped over all sorts of projects recently with organizations that are capturing large amounts of imagery but are not necessarily getting everything out of those photographs that they possibly can. Some of you have seen we've got some badges on the table and stickers that you can take home if you want to stick them on your laptop. One of them in there is dark data, and it might be a term you've not heard before. Dark data is effectively data that a lot of your systems in the business create. And it might be log files or chat content or information that's being passed between call centers or IoT sensors accumulating content that you don't manage to look at. The point is, it's dark because you don't get any value from it. You don't get to it, but you're creating it. The challenge is it's completely untapped potential. It very quickly becomes out of date. It's an environmental nightmare because we're creating all this data and we're storing it, probably doing nothing with it. So we're having to back it up and often store it in triplicate. The machines that are running to power that capability. There's probably compliance issues in there. There's probably challenges around what you're hanging on to. So it's a frustrating problem. You've all got this problem. Just look at your own camera roll. I mean, you've probably got too many photos of a dog or a kitten that you care deeply about, or what you ate last night, just on your own camera roll. Stored in the cloud, probably, accumulated, probably, for me, do your expenses on the way up on the train. They're probably all sitting in your camera roll, all your little receipts. But if you think about this in the context of a site survey or some business data, this is a drone footage of a particular site, thousands of photographs looking at roof condition survey. What do I want to know? Well, I want to know if I've got a slipped or broken tile or my guttering is clogged, because the maintenance team need to go out and have a look at it. But they don't want to look at 10,000 photographs of roof tiles. They want to know which photographs to look at, and we need to try and help them direct their attention towards the imagery that matters, that they can then go and carry out an action on. It's interesting, the way technology has changed over recent years. Our devices give us new capabilities, and the concept of computer vision means that we can do face replacement on our children. I mean, in some cases, I'd quite like to replace my children, but the point is that you can use this kind of image analysis to look at a collection of images and pick the right one and merge them together automatically. You can classify your children, your pets, your your entire camera roll. We can go on holiday and we can find out what we're about to eat by scanning a menu with Google Lens and getting it to tell us and auto-translate. And that's just a re-badging of old 70s technology called OCR, or optical character recognition, where you put in FME there's a transformer called a tesseract caller. You can call a little third-party open source plugin to do optical character recognition. You can do much better variations of that now with some of the different AI services that we're starting to see. The challenge we've got is that your eyes, when they look at something, can assimilate what they're seeing and work it out and carry out an action based on what you've seen, but computers have to be trained to do that. They have to be trained to make decisions. The interesting thing is, I bet you've helped, right? I mean, how many times have you tried to log into a chat room or a website and you've tried to work out, is that actually, well, I'll tick that one because that's definitely got a lamppost in it. But this is capture technology that was created by Louis von Ahn originally. It's basically a way of keeping bots out of Yahoo chat rooms because there was a real challenge with sort of big hacks on sites. So the very early iterations of this were where you had to key in a word based on a raster image that you saw, and that effectively helped to digitize thousands upon thousands of physical copies that have been scanned and are now available in digital libraries. But that got easy, got easy to spoof, so went to images, and you're finding now that some of these can be beaten, so we're seeing new capabilities come in. But if you've been helping train here, these big digital libraries of different tagged images have been created, which helps some of these AI services these days. Why am I showing you a kitten and a raccoon? Well, there's a backstory to this, and if you want to know more, I'll tell you in the pub. But long story short was a guy I knew in North America had a raccoon breaking into his house and it was eating his cat food. And he wanted a way of trying to work out how he could identify what the animal was just outside the door to decide whether he'd let it in or not. There's other ways of solving that problem now, but he was a techie. He wanted to do it with image analysis. So let's have a little look here. So we've got a workflow, if I can just kick it off. There we go. So I've got a workspace here, and we have a recognition connector. So AWS Rekognition is a image analytics service provided by Amazon Web Services. It was launched in 2016, and there's a transformer that was added to FME in 2017, and it does things like PPE detection or object detection, face detection, text content. So you can throw an image at it, and in this case we're going to do some object detection. And I use a feature reader to read in my image of a kitten and a raccoon and see if I can differentiate between the two. And it's quite tough, with some of these early tools. So there's my animals. I'm going to pass them into the recognition connector here, and I'm going to do object detection on it. And you'll see that when it comes into the attribute manager there, it gives me a bounding box, and it tells me that the object on the left is a cat and the object on the right is a dog. Okay, so we've failed. If we sort of nudge this on a little bit, you can see that we can move more towards dedicated tools. So we did a project a little while ago, and we used a service called Ximila, X-I-M, or similar, it can be pronounced, I suppose. So this is an image tagging service. So it's an AI image tagging service, and we wanted to effectively pass our same image into the process here and generate a list of keywords. What we have to do, though, is because the API for Similar expects us to provide an encoded image, we have to turn it into a little blob, and then we can attach it or pass it into our API as part of the request. So instead of sending the API the actual image, we put it into the request as a base64 encoded image. And then once we've authenticated against the API, we get a list of keywords, and you can see we've got an animal, a cat, a feline, a mammal. We've got 2 cats. So we originally had a cat and a dog, now we've got 2 cats. We still don't have our raccoon. So this sort of service was very specifically used for a project I'll touch on in a moment. we're now into as Oliver and Simon were talking about, the new guard. Well, the new guard of AI, OpenAI and Gemini. Here, using one of our little custom transformers to hit the service. Have a look at this image. Our prompt is go and have a look at it and tell us about it. And you can see here, there's a domestic cat. Here's its scientific name. Its identifying features include a relatively small round face, etc., etc. On the right side of the image, we've got a raccoon, finally. So you can start to see that this is a way that you can get some descriptive content from the images that you're passing in. If you go and look at Gemini, you've got a similar scenario with Google Gemini. Gemini is very good for image analysis, so you can see here a similar scenario. We get our scientific name back, and Gemini is starting to give us an indication of things that aren't actually in the picture. So it's got a bushy tail, but it's not fully in the image. So you can start to see that it can give you further detail that is available. So what I'm going to do, I'm just going to flip this on the head. The whole point of this really is to sort of highlight a little bit of the project work we did. So we've done some work with an organisation called Workspace Group, and they had a scenario where they needed to load thousands of photographs of office spaces into their digital asset management system. And you can see here, this is us using the Rekognition connector, just analysing an image of an office. And you can see that you can pick out individual features. So we've got chairs, we've got dining tables, we've got a plant. There's more than one plant on the shelf, but we found one of them. So you can start to see, at the top you've got sort of older tools, down at the bottom of the workspace you've got newer ones. What we needed to do was we got involved with Workspace Group, and we needed to load their photographs into their digital asset management system. But we needed to solve the problem of someone rings up and says, I want an office in Islington, but I want wooden floors and I want natural daylight. Okay, well you can't do that unless someone goes in and keyword tags all the photographs. So as part of our data transfer and load, where we took photographs from SharePoint and put them into their digital asset management system, we also passed them through to Zimmer and keyword tagged them so that they could have some metadata against the photos. When you start to use tools like OpenAI and Gemini, this is where copywriters and marketing people get nervous, because the quality of the response often is all about the prompt, how you ask, and the context you put the service in. But you can actually pre-feed an AI with things like brand values of an organisation, so that you can get the response back that matches your corporate approach to something. Talking about the lighting or the mood or the contemporary feel that particular building has. So we've got a little scenario there. If you want to dig into more, have a look at the Workspace Group case study that's sitting on Safe Software's website, and that will give you a bit more detail about that particular project. Oliver has already touched on the fact that we've got a verified status for our FME hub. This is kind of the app store for FME. You can download custom tools. As a verified provider, the tools that we've made have been vetted by Safe, and all of ours, I think, bar none, I think they're all a tool that integrates with an AI service. So we've got Llama and Google Gemini and OpenAI tools that are able to download. Just add your own API key and you'll be able to connect to those services. When it comes to computer vision, we've also been doing some R&D, which we then took into a project, a utility project. And it's a really interesting bit of technology. I'd urge anyone here mildly interested in this topic to go and have a look at Roboflow. Roboflow is an interesting platform. It has a concept of a universe. So if you're interested in computer vision and sort of, the old training of, if you're working with this type of service, you might expect that we'd have to be doing, thousands upon thousands of images to train these sorts of services, but actually there's a whole community here of people who've created machine learning models for face detection or analytics of sports events or bone detection in X-rays or product detection in retail scenarios. And if you click through to any of these, you'll discover that there is an API endpoint at the end of them, and you can also take the photographs and you can contribute to them. So if you're happy for your data to be publicly shareable, then you can contribute to someone else's model. But if you create an account, you can have one hidden behind the scenes and you can use it for your own private use. So what does this mean? Well, it means that you can start to do traditional orchestrations. So we've got a scenario here. There was a photograph at the start of this session that had some vehicles in it with number plates. ANPR, or automated number plate recognition, is the kind of thing you hear about in police camera action. That's probably a bit dated, that reference, but whatever the current version of police camera action is, yeah, look at this clown, the kind of commentary that you get. Take an input of some photographs. We're going to use Roboflow to find the number plate in the photograph, and then we're going to take the number plate value and we're going to identify the text that is the number plate with Gemini, because Gemini is very good at lifting the text out of a photograph, and then we're going to send a request off to the DVLA to find out if the vehicles in the image are taxed and find out a bit more detail about them. So it's very, very traditional orchestration. So if I just run that through, there we go. So here's our feature reader, and we read in our image. Same challenge as before. So the API of Roboflow requires an encoded image. So we're going to grab the photograph and encode it, and then pass it into our request to Roboflow. And we can go over to our HTTP caller, and I'm just going to run our request here, but you can see that here's the request that we're going to say to Gemini. So find the registration plate, respond in valid JSON, and this is the structured response that we want, so that we can then parse that as part of the workflow. So if we run that workflow through, it sends one photograph, admittedly. This is a demo, but you could do more than this. Extract the image, binary encode it, and then send the request to the HTTP caller here. And you can see that I'm hitting the license plate recognition API that's in the Roboflow community. Here you can see it is. You can see there's 10,125 images have been contributed, and people have gone through and have tagged those, and you can see there's an API at the end. So there's an element of automation, and you'll see that in a minute. You don't have to tag every number plate in every image. It learns as you're tagging, so it makes it a much quicker process. Here you can see I'm then taking the response that comes back. In this case, I'm getting to identify, Roboflow is showing me where in the picture the number plate exists. So it's basically saying there that there is a little bounding box on the photograph, and there's a point, so it's an 80% chance it's a number plate. So we've got a fairly high confidence that in that pixel area of the image, we've got a number plate. So we then just take the coordinates that it gives us back, and we use that to build a rectangle so that we can find the area of the photograph that we want. And then we use the clipper, and we can clip out the bit of the photo that's got the number plate in. So then we are only passing exactly the bit of the photo that has got the number plate in it. There we go, there's our area of interest, that's the number plate. We clip that out and send that off to Gemini to say extract the text. Okay, so there's our little clipper process, and we effectively do a little efficient cookie cut. And that saves us bandwidth and effort when we're sending the data to Gemini as well. Okay, and then you can see here that we have our little Gemini bookmark where we send our request off, and we get back our structured JSON because we asked for structured JSON, and there we go, there's our registration plate that matches the reg plate in the image. And then all we need to do is you go to the DVLA and create an account, and you get an API key, and then you can make a request to the DVLA, and you can pass in the number plate, and you get a response back to tell you the vehicle type, the colour of the car, whether it's got a valid MOT, etc., etc. And you'll see I've got two that go through the top section and one that goes down the bottom, and we're going to focus on the two at the top and not the one at the bottom, because there is a valid response from the DVLA about the two at the top, and you can work out the rest. But you can see here that we've got a BMW and a Mercedes-Benz, year of manufacture, etc., etc. So there you go. Just gives you a scenario. Anyway, the reason why there's two squirrels here is because we were showing this to a group of people much like this in Leeds at the latter end of last year. And there was a guy mumbling about squirrels in the front of the room, and I was intrigued, so I went and had a chat afterwards. And he is involved with the Cumbria Wildlife Trust in the Cumbria region, volunteering and focusing attention on identifying and helping with the reintroduction of the red squirrel over the evil grey. What he was explaining to me was what he'd just seen could be really, really cool, because he had hours and hours of trail cam footage where they'd mounted trail cameras around the area, and he didn't want to trawl through those videos to find where there were existence of red squirrels. So we helped him build a little process to read in the movie image, pass it to an open source utility called FFmpeg to chop up the video into individual still photographs, take the still photographs and send them to a trained model that had been partially contributed to the community and he's then added to in Roboflow, and then identify the individual points in the video where there was an existence of a squirrel that was red. And that was his solution. And it was a tiny challenge for a charitable challenge, but it would have been hours and hours of reviewing blades of grass and leaves moving slightly to the left, and instead now he knows where all the squirrel locations are. And the point is that from a utility point of view, we've got similar challenges. So we've just done a piece of work with UK Power Networks, thousands of scanned documents that included this incidence of a curious arrow, which is a cross-section. And basically we needed to quantify how many cross-section drawings there were that we had to do work on. So we wanted to do that by identifying how many little arrows there were. So we basically used FME and Roboflow and Gemini to solve this problem. So this kind of traditional machine learning challenge, there are out-of-the-box tools. There's a lot of training that goes into prepping them. They can also be a bit of a black box. You're not quite sure how they're identifying the features, and you don't have the ability to swap out the models underneath them. Roboflow's got built-in tools that allow you to deal with brightness challenges or rotation or exposure or noise in the images as well. You can see the kind of volume of training data sets, so a few hundred images. And as I said, when you go through and upload your training data set and start drawing boxes around the arrows, after 2 or 3, it starts to give you boxes around the image that you're next moving on to and saying, is this what you're looking for? So then you can just validate that and move on to the next one. So actually, once you get going, it's really quick to get a training data set in place. And you can see this is the kind of training interface where you're identifying the individual arrows that are of interest to you. And you can get an export, so you can see there's a few different ways you can get output, but here you can see there's a JSON response there, and it will give you an indication of confidence levels. What you'll notice in most of those, against all of those little arrows, you'll see there was a little number in the corner. It's the ID number of the cross-section. So we needed to extract that as well. So it turns out Gemini is pretty good at getting the text, as I've already alluded to. So we just buffered the box that Roboflow was identifying where the arrow was, because inside that box of a certain tolerance there would be a number. So we then clip it out and send it to Gemini and get it to extract the number. And your traditional orchestration, have you seen FME processing to Roboflow to grab the arrow, to Gemini to grab the number, writing the data out to GeoJSON, and you'll see it better. Yep. Up in the top right hand corner, you can see the number 50 associated with that particular bit of geometry. And it took about a day to train the model and get the data correct, but you were getting 75%, 80% confidence response at the end. So hugely valuable. And for us, in terms of preparing and batching up the workload that we were going to have around the cross-section work, it meant that we could, bundle the data up and work with our team to do the rest of the necessary data capture. My colleagues have all been involved with safe software webinar of one description of another over recent months. So you can see that Siobhan did a session on AI agents. Oliver's been involved in the Gemini session, and Simon did some work there with Amazon Bedrock. So those are all on the webinar on demand page, so you can go back and look at those separately. This is also, I mean, I listen to a lot of podcasts when I'm making stuff. This is a great one. I really enjoyed The Artificial Human. There's some really interesting topics on BBC Sounds. So if you're interested in podcasting, then that's an interesting one to listen to. And just to finish up, if you want to have a little play, if you scan that, you can have a little play. We've got a little workspace that's sitting behind an app. And it allows you to take a photograph of something in the room. This is going to go to a public service, so take a photograph of your shoe or your bag or something basically that isn't someone's face and it isn't something that's data sensitive. But if you scan that, you'll get this app will appear. If you scroll down a little bit, there's a section that says upload files. Don't do that. Push the very tiny hyperlink that you'll see on your device that says browse file system. And that will activate your camera. And then you can take a photograph of something. And you can upload it and then hit run. And basically you'll take a photograph and it's going to send it to Gemini. And Gemini is going to have a look at it. And in our prompt, we're telling Gemini, go and have a look at the photograph of the thing and assign one of 15 different data types and then come back with a pithy response that describes the thing in the photo in the context of the data type. So it's just a little bit silly, but the point is that you'll get a response something like that. So you're going to classify yourself as a data type, and in this case, it looked at my bag and it said that you're as open, you're open data, and you're as open as that unzip pocket on your backpack. It's a little bit of silliness, but the point is that you've got the ability to prompt the service in a particular way, set the AI in context, give it a set of classifications, tell it how to respond, and in this case we've kind of wrapped that all up into a dedicated app. And we've got a very small machine that's got a couple of engines sitting behind the scenes servicing that, but it gives you an idea of the kind of thing that you can do. So thank you. Cheers.